Hi guys, BuildZoid here, and today we're going to be taking a look at the TRX40 Creator from MSI. And so MSI sent me one of these boards for testing, so big thanks to MSI for providing the board, though they also provided the pictures. And I do believe that this is an engineering sample board because it doesn't have the M.2 like mounting stuff in like soldered on, because that should be in like populated, and it's not. So though I actually don't pay that much attention to M.2, so it might just not be like screwed on. Like, I'm not sure right now. Anyway, yeah, so the Creator TRX40, it's $700, and I have like my one major complaint for this board is see this? Yeah, see, this is why if you come up with a naming scheme, you should stick to the naming scheme and not randomly change it to your competitors. So here's the thing. For X299, MSI released the X299 Creation. For X399, they released the X399 Creation. For X570, they released the X570 Creation. And for TRX40, they released the Creator. For X570, ASRock has an X570 Creator. And I think for X299, they also have a Creator motherboard now. And then for TRX40, because they've already used the Creator name before, they made another Creator board. This is like, so in my opinion, MSI going and copying ASRock's naming scheme, dumb. Like, this is really dumb, especially considering that this board is like $460-ish dollars and this one's $700. It's like, why would you want to share your product name with something that costs like significantly less? And like your potential buyers are just gonna like check out the ASRock board and maybe decide that, you know what, maybe they don't want to spend $700. Like, I'm just saying, it doesn't seem like the best way to try, you know, like, yeah, it's just like, it's dumb. Like, this should have been the TRX40 Creation as far as I'm concerned, because at least it would be like, because the other thing is like, if you want people to recognize like a product name, you need to keep using it. Because otherwise, like, if you keep changing product names basically, like, there was a time when motherboard vendors were changing product line names literally every chipset revision, and it, like, well, every new chipset release, and it was just like, well, nobody knew what anything was because the names for, like, the low end and the high end were getting redefined every single release, and it was just like, just make up your damn minds and stick to it for like, you know, what, for like 3 chipsets instead of just one. Well, I guess MSI met the 3 chipset quota. They used Creation for X299, X399, and X570, and now it's like, well, now we need a new name, guys, because evidently Creation is not cool enough or whatever. It's like, and the thing is, they didn't even like, same freaking thing, and now it's just like, oh yeah, there's an ASRock board that costs significantly less and has the same name. I wonder what it does. So yeah, like, calling this the Creator instead of the Creation is just like, it's dumb. Like, it's just dumb. So anyway, with that out of the way, let's talk about some of the features that this motherboard comes with. And in that department, I mean, we've got the 10 gig LAN, which, you know, if you're observant, you would have noticed the great big 10 gig LAN Aquantia chip right here. But yeah, you've got the Aquantia 10 gig, then you've got the Intel 1 gig, you've got a bunch of USB ports, you've got a clear CMOS button, you've got a BIOS flashback button. The motherboard does not have dual BIOS, which in my opinion for a $700 board is kind of ridiculous, because the board's $700, BIOS chips are not very expensive. Why doesn't it have dual BIOS? At the same time, like, the thing is, BIOS flashback can actually, like, the main use of having dual BIOS is that it can recover from corrupted BIOS flashes and that kind of, and other other types of BIOS corruption. BIOS flashback can technically do the same thing most of the time. Like, there might be some rare cases where it doesn't work. There are also some rare cases where certain, like, say, Gigabyte's automatic dual BIOS doesn't work. which is why I prefer the hardware physical switch for changing your BIOS chips, dual BIOS implementations. But anyway, yeah, so you've got the BIOS flashback, so you can do like recovery. But the other major benefit to actually having dual BIOS is that if you want to test a new BIOS release out, you can install it on like your secondary BIOS chip, and then if you don't like it, you don't need to do a BIOS flash. You can just go back to your old chip, right? And if you do like it, well, you can just stay on the chip that you flashed, right? Like, it makes BIOS updates less of a hassle, in my opinion, because the other thing is like you're not actually going to use the flashback like I wouldn't use the flashback function for regular BIOS updates. I would just do that through the BIOS of the motherboard. But yeah, so I still think like on a motherboard this expensive, you should have dual BIOS. I don't like. I'm pretty sure there's enough space to fit an extra BIOS chip somewhere, right? Like, well, nah, there's probably space somewhere, right? Like without knowing for sure how everything is set up, it's just like there's probably space. Or you could maybe like you could even daughterboard the second BIOS chip if you have to, right? Like, it's not that bad. Anyway, then there's also Wi-Fi 6, of course. So pretty standard rear I/O configuration, right? The clear CMOS on the rear I/O is nice because it does mean it's accessible if you have the motherboard inside a case, which is apparently a thing that most people do. I obviously only run test benches. Anyway, down here we've got a postcode, we got some power button and a reset button. The postcode is in, of course, the worst possible location for a postcode on a motherboard that's meant for a workstation platform because, like, you're probably going to maybe want a lot of different PCIe devices. They might end up being pretty long, and you're not going to, and it's going to cover up your postcode, and then it's going to become completely bloody useless. Great. Yeah, no. Like that postcode should be somewhere else as far as I'm concerned. So not really a fan of that being down there, but at least, if you're doing test bench use, then power button reset. Well, yeah, power button, reset button are present. They're not exactly accessible if you wanted to run like a multi-GPU setup for benchmarking, but at the same time, Threadripper really isn't that great for Threadripper, from what I've seen, is not that great for 3D Mark like for anything but like Time Spy. And so it's just like, or actually it might just be Time Spy Extreme, very specifically, like just Time Spy Extreme. So it's just like, yeah, well, not really a concern in that consideration. Like that's not really a realistic use case because of that. It's like, why would you run 4-way on this when you could run 4-way on X299, which thanks to Intel lowering its prices is now cheaper. Admittedly, that's like, dumb things for people like who care about Firestrike scores not actually being productive. If you care about being productive, then Threadripper does have a lot of advantages. It's just not great at 3D Mark. So yeah, that's kind of why I'm not that interested in it. But anyway, you've also got some debugging LEDs up here, which are made mostly like they're redundant until your postcode gets covered up by some expansion card. So yeah, and then they suddenly become very useful because your postcode is invisible. So that's kind of all the features we have on the front of the board. It's not really like, we don't really get anything super crazy here, which I don't know. Yeah, I'm not sure. I would have liked to see something like, say, dual BIOS, safe boot, postcode in a not stupid location. But yeah, like, the basic things are here. And then if we go on to the back of the board, we get a sort of very extreme overclocking focused feature. We get this hole in the CPU socket, which is for putting thermocouples through, though technically you could also like solder voltage probes through that, though good luck squeezing them through that hole. But yeah, you can put a thermocouple through that and basically monitor the CPU temperature without having to rely on like the built-in temperature sensors of the CPU, because those don't tend to work very reliably once you're very below zero. So yeah, it's kind of like, the thing is, this is MSI's sort of like, I don't think, well, yeah, I'm not sure that they're going to be this basically seems to be MSI's flagship, and MSI obviously does do a little bit of extreme overclocking. It's not on the same, like I'd say right now, like basically the heaviest extreme overclocking support is still from Asus. They still go above and beyond with just tons and tons of LN2 overclocking features. But, you know, like MSI still does actually participate in extreme overclocking. And so, you know, you do get some features like that on their flagships. So that's still kind of nice to see, though I've personally actually never used one of those. Well, actually, no, I have used one of those holes for voltage monitoring, not for actual K-type thermocouples. So I've never used it as intended. Anyway, if we go to the back to the front of the board, now we're going to talk about the power delivery, because, yeah, in that department, I mean, the thing is just, I wish I could say this is something like super ridiculously awesome and special, but it's really not, because this is kind of the norm for TRX40 motherboards. So this right here is the VCore VRM. And it is a real 6-phase, because MSI has started using the great, the amazing XDPE 132G5C from Infineon. So this is a true 16-phase voltage controller. I can't believe that took me so many tries to say. Yeah, it's just got 16 phases, so you don't need to worry about doublers slowing down your PWM signals. You don't need to be concerned about a low phase count causing higher input ripple and that kind of thing. You get perfect current balance per phase because the controller sees all 16 phases. Like, this is the best way to run a VRM. But the thing is, Gigabyte was kind of first with this, and they're of course using it on their TRX motherboards as well. And well, yeah, that's kind of that. So it's just like, yes, this is the new best voltage controller you can use, but there's kind of a lot of motherboards that already use it. So it's like, yeah, there's other like if you want this VRM, there are other options, though there might be sort of like there can still be performance differences, because even with the exact same parts, the implementation matters. So because, you know, there's firmware for the controller, which depending on how that's set up, you can get different results. Then there's of course the actual you have other, you know, considerations like what kind of inductors you're using, what kind of capacitors you're using, how is the power plane laid out, where are the capacitors located, right? That kind of thing. So ultimately, it's just like, if we just talk about the controller and the power stages, there's other options that do the exact same thing. If we're looking at the overall performance, you'd actually have to go ask like if you wanted to look at the sort of voltage regulation performance, you'd have to go ask an oscilloscope. And unfortunately, I'm not sure that I don't think I'm going to try to do VRM voltage regulation comparisons on TRX40, just because I think the socket on this platform is just too much of a, like the socket can mess with too much in terms of the data. So yeah, though I'm still like, I might need to figure out I'm still looking into various measuring methods. So yeah, we'll see. If I figure out something that's not invasive and doesn't need, you know, wires directly attached to the CPU, then yeah, maybe I can do some VRM performance comparisons. If I can't figure out anything like that, then forget about it, because I'm not doing there's no way I'm modifying the CPU on these. Anyway, so that's the control scheme of the VRM. For the actual power stages, we're looking at 70 amp smart power stages from Infineon. So that's the TDA 21472s and 2147. Really? It's just okay. Took me less time to write than I expected. Yeah, so 21472s, and yes, that 4 looks weird, but we'll leave it alone. So these hit peak efficiency at 20 amps output, which is just a little bit under 94%, while pushing 1.2 volts. At higher voltages, the efficiency gets slightly better because you have less current. The increase in heat dissipation due to more current through the high side is less significant than the increase in output voltage. So you get more power out at the same current output. So anyway, at 1.2 volts is like not peak efficient. Like you can get better efficiency at higher output voltages, but at 1.2 volts, a little bit under 94% efficiency is still really, really good. So yeah, and these are called smart power stages because they integrate better current monitoring. They also integrate temperature monitoring, over temperature protection, over current protection, and a bunch of other protection features that I don't really care about remembering. So anyway, the end result of these lovely power stages is that the VRM has the following efficiency. For 1.2 volts output, 400 kilohertz switching frequency, and 5 volts drive voltage, you're going to be looking at the following performance. So 200 amps output, it's going to produce about 16 watts of heat. So VRM doesn't really even need a heatsink. 320 amps output, the VRM is going to produce about 25 watts of heat. So depending on the airflow situation, you could actually get away with that with no heatsink. Like, this does have a lot of surface area inherent to just how many power stages there are. Yeah, like the board comes with a heatsink, so you don't have to worry about that. So that's going to be fine. And then 400 amps output, which is sort of like, this is the theoretical upper limit for like a 32 core. I'm not sure if we're going to see the 64 core on this socket. The 64 core theoretically would go all the way up to 800 amps. It may or may not be practically coolable at that point. I'm leaning towards won't be. But theoretically, 800 amps is not impossible if there was for like a 64 core Threadripper. It's just kind of like good luck cooling that. Like, you're probably going to have CPU thermal issues before the VRM becomes a concern. But anyway, for the 32 core, that's less of an issue. Even though, like, 400 amps at, say, around 1.3 volts, yeah, that's going to be that's over 500 watts of power, which is not impossible to cool, but it is very difficult to deal with. Anyway, the CPU, like the VRM, while pushing that amount of current, would produce about 32 watts of heat, which with the heatsink that this motherboard comes with, which unfortunately I don't have a picture of right now, but you can look up the pictures of the motherboard, like, it has a very substantial VRM cooling system. So that is not a concern whatsoever. 32 watts, for the heatsink that this comes with, should be no problem whatsoever. Going up to 600 amps, this VRM will produce about 59 watts of heat, which is like, depends how much airflow you cram through the heatsink, though it might still be able to do it passive. And then 800 amps, so that's where, theoretically the 64 core would land, which also this would actually exceed the current, the power handling capability of the 8-pin power connectors. So this motherboard wouldn't be able to do, like, you wouldn't want to run that long term on this motherboard just because the power connectors won't deal with it. And for that, you'd be looking at like a 64 core running over 4 gigahertz at 1.3 volts. That's what kind of operating, and that would be in Prime 95 small FFTs, which is why, like, it's a kind of ridiculous worst case scenario loading, but it should theoretically be possible because an 8-core CCD Ryzen 3rd gen under small FFT Prime 95 at 1.3-ish, like 1.3-ish volts, like, it doesn't need to be specifically exactly 1.3, will pull around 100 amps. So yeah, like, this is theoretically doable. Practically, maybe not. Anyway, at that point, the VRM would produce about 96 watts of heat, and you need here's the thing. Like, technically speaking, if you apply like absolutely ridiculous amounts of airflow, so we're talking like server grade fans, that would maybe be coolable. And by server grade fans, I mean, in excess of 6,000 RPM. So very, very loud, very power hungry, and capable of moving just insane amounts of air. So that could actually be coolable. A VRM water block would actually have no problem with that. But practically speaking, that is not a realistic consideration for this motherboard, or really any TRX40 like, the thing is, like, that's actually where all TRX40 motherboards top out theoretically, because they all basically have some variant of, well, there are some boards with 90 amp power stages, but I've not looked into those too much yet. But basically, a lot of motherboards, you're looking at 16, 70 amp smart power stages, and that's kind of that. So yeah, anyway, for the CPUs that we do know for a fact go into this socket, you're going to be in this range. You're not going to go above 400 amps, and this motherboard is more than enough, so really no concern. And I guess also, if you're running a 64 core, it's probably just a straight up render rig, and you're maybe, like, you might actually care about power efficiency in that case, right? You're not just going like, I need to finish Cinebench as quickly as possible. because that, well, and Cinebench doesn't pull that much power either. So that's the other thing, is like Cinebench doesn't even get that hot. It's just like, so yeah, you know, if you care about max stability at 24 hours, 24/7 load, you probably also have some, you know, care about actual like efficiency of the system. And running a ragged edge overclock, sure, it might be fast, but if you back off a couple hundred megahertz, your power consumption drops off, like massively decreases, because of the way your frequency versus voltage scaling versus power consumption scaling works out on basically any type of silicon. It's just like, yeah, if you want to run the highest possible frequency, your power consumption is going to suck relative to if you ran a couple hundred megahertz less. So that's, you know, not really a practical concern, but theoretically it might be possible. So yeah, which does mean like I'm not really a fan of this dual 8-pin power configuration on this motherboard specifically, because MSI uses, if we hide this, you can see that these are flat tabs coming out of the holes for the power connectors. MSI uses the folded metal power connectors, and the folded metal pins, they are the lower current variant of the 8-pin power connector. And that basically means that you're only looking at like 384 watts power capacity per connector here. And, well, I think they should have gone for the solid metal pins, just because that alone would bump you up into like the 480 watt range. Or they should have done what they did on the X299 creation, which was they had a third 8-pin. Which is just like, which I don't like the idea of a third 8-pin. I would have gone for a 6-pin PCIe connector, just because triple 8-pin power supplies are just kind of like, that's weird. Like, it just is. Like, triple CPU 8-pin is weird, but a extra 6-pin, like 6-pin connectors aren't rare. So, you know, I would have added just an extra 6-pin and gone like, yeah, if you really want to push the limits of the motherboard, you should have, you know, you should plug that in. Yeah, as far as the actual VRM is concerned, like this is plenty powerful. Not really a fan of this, but if you're on a 32 core, this is not really a concern. It's just like, you know, higher core count CPUs might bring up some issues. So, yeah. Anyway, moving on from the CPU VRM, let's talk, well, the vCore VRM, because technically the SoC is still part of the CPU. We get the SoC VRM. What a transition. This is a 3-phase. And this is actually also very standard for TRX40 motherboards. Now, there are some where you have only a 2-phase SoC, especially at like the lower price points. Yeah, so this is a 3-phase controlled by a 35204 IR, of course. So that's International Rectifier, which is the same thing as Infineon, because Infineon owns IR. It runs as a 3+0 controller right here, though it can go up to 3+1. And we've got more TDA21472s, so more of those lovely 70 amp smart power stages, which does mean that the SoC VRM here is capable of pushing, say, 60 amps while producing 5 watts of heat, which is nothing. And also, I'm not sure that the IO die even pulls 60 amps. Like, that is something I'll need to test, but I don't think it pulls that much current. So this is, like, the reason why this is actually really, like, kind of overpowered for the SoC power requirements, or at least should be pretty overpowered for the SoC power requirements, is because this VRM obviously doesn't have as, like, because of where it is, it's kind of like you don't really want it running really hot, because there's like controllers and other things around it where it's just like, yeah, the VRM might not care if it was at 120 degrees, but this might, that might, right? Like, you don't want your VRM cooking everything around it. The other thing is like that it doesn't really get priority cooling here. It does still have a thermal pad attaching it to a very large block of aluminum, but it's not the same. Like, it doesn't get the same treatment thermally as the vCore VRM, where you just have a ridiculous fin stack right over it, as well as heat pipes going, going over it as well. So yeah, with this, you actually kind of want to keep the power, like the heat output down, just because, well, it's not you don't want to put a lot of cooling, like you don't want to be cramming a lot of cooling capacity into the rear IO area. It just doesn't really tend to work out too well. Anyway, so that's why that's so powerful, and this is pretty standard for most X399, TRX40 motherboards in terms of the phase count, and even the power stages to some extent. What's kind of noteworthy about the SOC VRM is that it is all polymer SMD capacitors for the output filtering. Aluminum polymers at that. Like these are technically tantalum polymers, so saying polymer is just like, well, that's a lot of different types of capacitors there. So yeah, aluminum polymers SMD, 2-terminal variant, and these are basically just better ESL, better ESR than your through-hole capacitors, though. As far as I'm concerned, the main reason we're seeing these here is not for some, electrical design considerations. It's just like, well, through-hole ones don't fit on the back of the board. Right, like there's not enough space in this area of the motherboard to use the larger variant, so that's why they went with the SMD ones. Anyways, that could have some advantages for voltage regulation going towards the SOC VRM, though I think there's also a lot of other TRX40 motherboards with the same output filter for the SOC, just because of the same space concern where it's like, well, it's jammed in the rear I/O area and there's no space, so you're going to use the low-profile SMD capacitors instead. So that's the SOC VRM. Nothing like, plenty powerful, but nothing ridiculous, like nothing super special by TRX40 motherboard standards. Now, the memory power delivery is where MSI is just like the thing is it is super overkill. Like insanely, ridiculously overkill. And just like, it also matter, like of all the VRMs where it's just like going mega overkill, memory power delivery is the least important, I'd say, because like here's the thing: if you actually care about memory overclocking, you're probably going to want to pick up a mini ITX motherboard or some other motherboard with only 2 DIMM slots, and those tend to be kind of cramped for space and don't really tend to go like ridiculous on the power delivery, because the thing is, with memory, the memory sticks themselves don't pull that much power. The memory controller also doesn't really pull that much power. And the priority really is about what you do with the trace layout between the DIMM slots and the CPU socket, not so much about what you do with your power delivery. But anyway, MSI has just gone like full MSI here, because to be fair, like this is a thing that on a lot of the, like their Godlike series has had some of the most ridiculous memory power delivery for a while now as well, and it's just like, well, I mean, sticking to the norm by MSI standards. So that is an IR35204 voltage controller running in 2+0 phase mode, and these power stages are, of course, more TDA 21472s. That's right. You have 140 amps of power stage for your 4 DIMM slots. Like, for comparison, let's just take Gigabyte. Gigabyte's top-end motherboard uses like 3 discrete MOSFETs for its entire memory power delivery. That, like, Gigabyte's power delivery for memory is like 1/5 the current capacity of what this has. It's still plenty good enough for memory overclocking, especially because I'm not sure, like, I'll have to see about this, but I'll be surprised if Threadripper doesn't do the same thing as Ryzen does, where it's just like memory speeds above 3800 megahertz are complete wastes of time, just because your FCLK doesn't do what, like, your FCLK is not able to go that high. But I don't know, maybe the different IO, like this does have a bigger IO die, so it might be significantly different in terms of how that interacts with the actual memory sticks. But yeah, I kind of doubt it. And in that case, it's just like, well, the thing is, the memory overclocking is really going to be like, it's just going to be mostly about the trace layout. It's not going to be about the power delivery. But you still can't deny that this is like, I'm pretty sure this is the most powerful memory power delivery on the entire TRX40 platform. So yeah, it's just that I'm not sure that it actually does anything. Also, on this side, we have a bunch of SMD aluminum polymers for the output filter of the VDDR, whereas here we just have through-hole aluminum polymers, and it's just like, well, again, space concerns, right? Like there's an M.2 slot that goes here, and that's why these are SMD, I assume, whereas these, they're just through-hole because, well, space. There's plenty of space for them there, so why not use them? So anyway, for the actual memory topology here, we are looking at a daisy chain, which is just standard for the Ryzen memory controllers. It just seems to be that the Ryzen memory controller plays best with this topology. So of course MSI is still using it, and I assume actually all of the I assume all of the TRX40 motherboards are using it as well, because it just seems to work the best for all memory configurations in general, and it does give you an advantage if you are only populating your those 4 DIMM slots, which the motherboard also helpfully tells you directly on the motherboard. I do actually appreciate that. Motherboards where you have to look up go into the manual to figure out which DIMM slot is what is kind of annoying. Though most motherboard, like with 99.9% of modern motherboards, you're going to be going outer DIMM slot first, just because of how the memory traces are configured. So, yeah. Anyway, I think that's everything about the power delivery. Yeah, there's really not that much to this. We've got the arguably pretty standard ridiculous 16 phase. Well, it's not really that ridiculous, but very powerful 16 phase nonetheless for VCore. We've got the standard 3-phase SoC, and then we've just got massive ridiculous VDDR power delivery, which is just like, well, it's an MSI motherboard. It's a high-end MSI motherboard, so what did you expect? Reasonably sized memory power delivery? I'm not sure MSI knows how to do that unless they're forced to by, building a mini ITX board. Anyway, also for all of the through-hole aluminum polymer capacitors around this motherboard are Nippon Chemicon, so that's a Japanese capacitor manufacturer, and they are rated for 10,000 hours at 105 degrees Celsius. So, yeah, in physically, pretty standard. The motherboard does come with like an M.2 expansion card thing. I'm not really a huge fan of the fact that MSI decided to not add an auxiliary power connector for the PCIe slots. Right? Like we've got the 2 8-pins for the CPU, we've got the 24-pin for everything else, and theoretically, if you wanted to run like 3 GPUs gets kind of borderline on your 24-pin. Once you hit 4 GPUs, it's like the 24-pin is just straight up unacceptable, but this motherboard really isn't laid out for a 4 GPU setup, so that's not really a concern. But 3 GPUs, you'd go here, here, and here, and it's just like, will the 20, especially because MSI is again using folded metal pins, it's just like, that's not great. I really think on a motherboard that's this expensive, and also that's meant for workstations because the thing is or actually you might end up with a configuration that looks like GPU, M.2 SSDs, GPU, right? And then it's just like, because, maybe somebody's doing like a 3D rendering workstation, right? And in that case, like having a bunch of GPUs for rendering acceleration is like, that's a totally reasonable use case. And it's just like, well, is the 24-pin going to be okay with that? Not really, because MSI's on the folded metal pins, so their 24-pin is even weaker in terms of current handling capability than some of the other motherboards out there. And it's just like, this really should have had there should have just been like a 6-pin power connector somewhere along the bottom edge. Or really, like, anywhere in this area. GIMP, chill out. There we go. Yeah, so that's... Or they could have, there should have just been a 6-pin somewhere. Not down the center of the board. Like, there's a lot of motherboards where they put the 6-pin over here, and it's just like, no, that's not where it belongs. But it would have been better than nothing, though. So, yeah, that's one of my, other sort of, My 2 biggest complaints for this board are basically no extra power for the PCIe slots and the name. Seriously, this should have just been called the Creation. It shouldn't share its name with the ASRock Creator board. But yeah, other than that, it's a solid motherboard all around, right? We've got the sort of the basics for convenient overclocking. Though the postcode's in the wrong place, but that's kind of there's too many motherboards that do this. There's too many of them. So it's not a huge complaint for me when it's just like, why is it in the wrong place? It's like everybody does that. You're never going to win, Buildzoid. They're never going to put the postcode where it belongs. Up here, damn it. How hard can that be? Yeah. It's just kind of like, I don't know. It might be because the TRX40 platform just really isn't meant for my interests, right? I'm technically a content creator. I don't edit my videos. Whatever happens to be recorded when I press the start recording, between, me pressing start recording and me pressing stop recording, that's whatever goes up on YouTube. So I don't know what this video encoding thing is, mostly because I don't actually have it set that high in terms of quality. I don't think. I'm not great with OBS anyway. So yeah, that's the thing. It's just this really isn't a platform for me, and I'm just this motherboard just when I look at HEDT, my immediate thoughts are so many cores for running Firestrike, but this isn't good at Firestrike. So, or Vantage, or any of the other sort of old high multi GPU 3D marks, and it's just yeah, not for me. But yeah, solid motherboard all around. It's just you're really gonna have to make your own decision if the feature set is for you. Because for me, this is kind of well, I mean, it's a board. It's not bad. There's nothing for me to really complain about. But at the same time, I'm not really that super impressed. Well, no, there is the 6-pin concern and the name, but there's the PCIe slot power concern, but there's no other than that, there's really not much. The rest of the board is built solid. So I don't know, maybe MSI's BIOS will blow me away or something, and I'll be really impressed by that. But outside of I don't really expect to be that surprised. There's not that much you can do with a BIOS, so and maybe I'll regret that statement. But yeah, this is the thing, is just this platform. It's kind of like me not doing videos about server hardware is just I don't care about server hardware. I'm sorry. So this motherboard kind of starts falling into the same category where it's just well, it's really great for Cinebench. That's the thing, I guess. And yeah, for Cinebench, sure. This is perfectly well equipped for Cinebench. So benchmarking from my perspective. So that's kind of that. Anyway, so thanks to MSI for, sending the board over. And they also loaned me a CPU to do testing with. So thanks to them for actually making it possible for me to cover Threadripper, though I've not yet gotten my hands on a cooling system for it. So that's kind of why it's just we're only doing a PCB breakdown. No actual hands-on experience yet. Yeah. So that's it. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, you can support me directly through Patreon. There's a link to that down in the description below. And otherwise, you can go and check out the HOC Teespring store where there's shirts, stickers, posters, the usual YouTuber merch stuff. And there's a link to that down in the description below as well. Both of those help out immensely with running the channel. So yeah, I'd be really grateful if you considered either of them. And yeah, that's it for the video. Thanks for watching, and goodbye.